Hello, everyone. Welcome to the webinar. My name is Imaya Kumar Jagannathan, and I'm a senior specialist on observability here at AWS. And in this session, we're going to talk about AWS open source observability. So we'll go through a few slides, and then we can go to the console, and I'll show you how you can make use of the open source observability solutions that we launched in re:Invent last year. All right, so before we go too far in, let's talk about what observability itself is. So if you look at re:Invent last year, if you watched our Amazon CTO, Werner Vogel's keynote, he talked about this in particular. Observability is basically a term that originated in control theory, and it basically means that you can infer the internal state of the components in a system by learning about the external signals or outputs it is producing. So you might wonder how it differs from monitoring and what value it adds. Basically, the difference between monitoring and observability is that monitoring tells you whether a system is working, whereas observability tells you why the system isn't working. Also, if you set up good observability in your environment by using the right tools and processes, observability can also enable you to answer questions that you didn't know that you needed to ask. Okay. From an AWS perspective, we believe giving the ability for developers and operators to get deeper insights into issues such as errors, faults, latency problems, that is the internal states, okay, by correlating external signals such as logs, metrics, and traces across a variety of different services through powerful visualization, analytic abilities, and easy-to-use insights empowers observability of a system. We also try to push the boundary a bit further by trying to identify potential application issues through machine learning algorithms and all the collected data that through logs, metrics, and traces. So having said that, this is how AWS native observability tools look like. So all the tools that you're building on top of the CloudWatch and X-Ray platform, the services, is specifically built for solving specific problems. Like, for example, if you take Container Insights, that is a fully managed container monitoring platform that allows you to very quickly set up monitoring on your container environment, whether it's ECS or EKS or Kubernetes on EC2, whether you're using ECS Fargate. We support a variety of configurations there. So it allows you to easily collect container performance and health metrics, and also collect logs into CloudWatch, and also provides a very easy to use interface for you to make sense out of the metrics, visualize them, and also query logs, and including performance and application logs. So likewise, X-Ray Insights, which is a anomaly detection feature that basically analyzes traces over a period of time and identifies anomalies and highlights those anomalies so you can understand what happened in the trace data that was collected. So you can look at Lambda Insights, Contributor Insights, and all the other services that are specifically built to solve a specific problem with the data that we already have, right? So all these features also work together to give you the overall 360-degree view of what is happening in your application, how you can make use of this data to correlate logs, metrics, and traces. So one of the things that I want to call out is Service Lens, which is a feature that is within CloudWatch that allows you to easily correlate this logs, metrics, and trace data, and also sets the context for you to dive deep in if you need to. For example, if you want to dive deep into Container Insights to look at container metrics, you would be able to do that from within Service Lens, because it will guide you to the process, through the process, to identify issues. So there are lots of such native features within CloudWatch and X-Ray on AWS native observability tools that allow you to set up monitoring observability very powerfully, and they're all well integrated into all AWS native services. And that is how it looks like at the moment with AWS native observability services. You have the instrumentation options, agents that you have, CloudWatch agent, the X-Ray agent, even the X-Ray SDK that you can use to collect logs, metrics, and traces. You can send them to the services, and at the same time, you can use the insights features that allow you to analyze the data very powerfully. And while we have CloudWatch Service Lens that, like I mentioned before, that gives you the overarching integration into all of these specific features, set to the context so you can dive deep in and understand what is going on and troubleshoot your issues. So that is what the AWS native observability platform looks like at the moment. So since last year, when we announced options for open source monitoring, we announced Amazon Managed Service for Prometheus, Amazon Managed Service for Grafana, and also AWS Distro for Open Telemetry. So what this means is now customers have more open source options for them to choose from when to set up monitoring and observability in their environment. So with Managed Service for Prometheus, customers don't have to worry about managing a large Prometheus infrastructure. We'll take a look at how that works. And obviously for Grafana, it's a service we launched in partnership with with Grafana Labs, and customers are able to simply create something called a workspace, which allows you to have access to a access controlled environment, a Grafana environment that is highly available and secure and natively integrated to AWS, and you don't have to manage that infrastructure, and you simply can start using the Grafana features from within. And AWS Distro for Open Telemetry is a downstream distribution of the Open Telemetry project. We work very closely with the Open Telemetry CNCF project, and we make a lot of contributions. This is basically us taking a snapshot of the Open Telemetry upstream project, testing it, making sure it satisfies the performance and all the requirements that we need from AWS, and also it is in a position that we can actually support in terms of a product itself. So that is our AWS Distro for Open Telemetry. Just want to be very, very clear here that it is not a fork from Open Telemetry project. It's basically a downstream distribution. So any changes we make, we always make the change to the upstream project and then bring it into the downstream project. All right. So let's first dive into what Prometheus itself is. So Prometheus is an open source monitoring and alerting toolkit, and it has gained significant popularity in the last 5-6 years or so, simply because it has really powerful query language called PromQL. It is very flexible and very powerful. It's also simple to use. The PromQL or the Prometheus metric format itself, or in other words, called Prometheus exposition format itself, is really simple. It has a metric name, and also there's key value pairs called labels and values for them. And then by the way it is structured, it is multidimensional natively, so it makes it very powerful to collect high cardinality metrics and store them and query them using PromQL. And also there's strong open source support. There's client libraries available for Java, Go, C#, Python, and all kinds of languages that you typically expect to have. And there's several exporters. Exporters are basically little utilities that you can actually use to export metrics from an environment. And there's 150 plus exporters maintained by open source community that makes it super easy for you to collect metrics from your workloads. So if you have Redis workload that is running, all you have to do is simply run a Redis exporter. Similarly for Nginx and all that. So you just have to run the exporter along with your workload, and you suddenly have metrics that are exposed in Prometheus format, and you can scrape. So there's really the adoption curve is not steep at all, so it makes it very easy for customers to adopt. And some of the main features, we discussed a lot of things here, in the last slide, when we discussed the last slide. So one important thing that I want to call out in this slide is that Prometheus works in pull model. What that means is it basically has a Prometheus server that actually that you would deploy, and you would have your jobs and exporters that are running here, and Prometheus would basically go and pull metrics from those endpoints based on the configuration, the scrape configuration. Or basically that means that you would specify what the targets are, what the endpoints are, and what metrics you need to scrape from that endpoint. So that is the most popular model. But also when workloads that when there are workloads that are not able to expose metrics in the long term, and when you have short-lived workloads, you will be pushing the metrics to Prometheus server. So that's where you have this component called the push gateway that you can use to push metrics to from short-lived jobs, and that is also an option that is supported by Prometheus. So you can either choose pull or push, but majority of the Prometheus workloads or deployments are using pull model, which is very popular in the community. And also Prometheus has native support for service discovery in Kubernetes. It can automatically discover targets. Kubernetes API servers themselves expose metrics in Prometheus format, so it is really popular in the Kubernetes community. When we see EKS customers, they always like using Prometheus to collect metrics from their environment. And also Prometheus has another component called Alert Manager that can be used to push alerts to different destinations. You can have something called alerting rules in Prometheus that will validate your metrics, and you can, based on the validation, you can push alerts to different destinations like PagerDuty and email and all that. There's several targets that are supported. So Prometheus is there are multiple components, and those components are really don't care whether the other components exist or not, so they can work independent of each other. So it's really at least the Prometheus server and the alert manager and push gateway and all these things. So it's really powerful. So you can actually choose not to deploy alert manager, for example, and still use Prometheus server. So it makes it really flexible for you to use Prometheus that way. And also you can query Prometheus server using PromQL. But one of the most popular solutions customers use is Grafana, and we obviously are going to talk about the managed Grafana service, but you can also use the open source Grafana as well to run PromQL queries on Prometheus servers. And you can also, Prometheus has a web UI that you can use to run queries. But generally, for all visualization purposes, we tend to see most customers use Grafana for visualization. All right. So the challenges in self-hosted Prometheus is that although it's very flexible, it's easy to deploy, but there is infrastructure that you still have to maintain. So it becomes really challenging for you to manage a really large-scale Prometheus backend. So you have to ensure that you provide a storage to store lots of metrics, sometimes even millions, and you have to provide API availability so you can actually scrape metrics from multiple targets. So when you have large EKS clusters, when you have hundreds, so sometimes customers even have 1,000 nodes in one cluster, then that means you have multiple thousands of pods in those clusters. So it becomes really challenging for you to have an infrastructure that can actually support that, and also provide availability and all that. So it becomes yet another workload that you have to manage and maintain in addition to your actual business workload. So it becomes challenging for customers to manage large-scale Prometheus deployments, and that's where the open source projects such as Cortex and Thanos came to be. These are CNCF projects that are in Sandbox, I believe, at the moment. And these are projects that allow you to create powerful Prometheus backends that are highly available, secure, and at the same time multi-tenant, so you can actually have multiple Prometheus backends in your deployment. So we use Cortex. Full transparency here, we use Cortex in the backend. So we actively work with the Cortex open source project. We've made contributions to the project in optimizing block storage and shuffle sharding and all that. And Cortex is 100% PromQL compatibility. What that means is if you use the managed service for Prometheus, you can simply bring your PromQL queries that you're using today. You absolutely have nothing to change or whatsoever. So everything will work as expected. It scales very well. It has lots of cache layers for query responses. So it makes querying very fast, in the sense if you run PromQL, so the results are cached if it's repetitive, and you sometimes expect to get results back very quickly, even in tens of milliseconds. And also it supports S3 for long-term storage. We use S3 for long-term storage in our solution, so you have all the advantages that you get with S3 itself. And yeah, so that is the managed service for Prometheus, which basically is a fully serverless Prometheus-compatible monitoring service that you can monitor your container and even non-container workloads. It really doesn't matter where the metrics are from. You can even deploy you can even use the AMP service to collect metrics from EC2. It really doesn't matter. The AMP service provides a Prometheus backend, like I mentioned before. It's fully managed. It is highly available and deployed across multiple AZs by default. And it uses the same open source Prometheus data model, like I mentioned before, same PromQL, absolutely no change required. You don't have to pay any upfront cost, or there's no investments for you upfront. You only pay for what you use, and it's fully secure. The APIs are secured through AWS Zigbee 4. So, and also it is encrypted at rest by default. So you can expect the level of security that we would typically employ for a AWS service. For Prometheus. So here, this is how this setup looks like. The orange rectangle that you see in the middle, that is basically what the Prometheus workspaces or the AMP workspaces. So it has an ingestion endpoint. There's a querying endpoint where you can query metrics from, and there's the storage, the long-term storage is backed by S3. And on the collector side, there are multiple options for you to choose from. You can choose Prometheus Server. You can choose AWS Distro for Open Telemetry. You can choose the Grafana Cloud Agent. There are multiple options for you to choose from to send metrics to the AMP workspace. And for visualization, you can use the Amazon Managed Service for Grafana, or you can actually use your own Grafana that you manage as well. So it really, there's absolutely no problem at all. So it will still be able to talk to the AMP workspace or the querying endpoint. Okay. All right. So what we can do is we can probably look at Grafana quickly, and then we can go into the console, and I'll be able to you'll be able to follow me hopefully and see what I'm doing, and you hopefully you'll be able to follow and do the same things and create an AMP workspace and also query that using Grafana. All right, so now let's take a quick look at Grafana. So Grafana, as everybody knows, it really provides a really beautiful visualization for metrics, logs, and traces, and really all kinds of data. Grafana has several data sources that it can support. It really doesn't store any data to itself. It is primarily a visualization tool, and it can talk to many data sources, and you can write the same native query that you would use for that data source. Say, for example, you're querying a Postgres database, or maybe you're querying CloudWatch. You would use, if you're using CloudWatch, you would, let's say you want to query CloudWatch metrics, you would use the CloudWatch metric math expressions. Let's say if you're pointing your query to a Prometheus backend, you would simply be writing POMQL query. So Grafana is very powerful because it is really simple. It really is yet very powerful through visualizations. Allows you to visualize data extremely well. But that's yet another workload that customers have to deploy and manage and keep it secure, and deploy, upgrade, and keep the patches, deploy the security patches, and all that you would typically expect to do. So the managed service for Grafana is, like I mentioned before, it is a service that we launched in partnership with the Grafana Labs. It is scalable, secure, and highly available. We manage the environment for you. It scales based on the usage, and it has all the native integration with multiple AWS services. It's enterprise ready, and also you can upgrade to Grafana Enterprise from within the console through AWS Marketplace. And we take care of the billing, and the bill is included in the AWS bill itself, so you don't have to deal with yet another bill. And also, it is pay as you go, so we charge for active users, and there are charges for active users depending on what type of user the user is. Like two types of users in general: viewers and editors, or administrators. There are separate charges for that, and we only charge for users who actually logged in for the month. So even if you had 500 users, only 5 of them logged in for the month, you'll be only paying for those 5 users who logged in for the month. All right, so these are all the different consoles, data sources that we support from AWS perspective. The Prometheus data source, obviously, you can query CloudWatch, X-Ray, Elasticsearch, TimeStream, IoT, Sitewise, and whatnot. So there's lots of data sources that you can support, that you can use, and we are also working on other data sources as well. At the same time, when it comes to alerting, Grafana also supports alerting from within Grafana, and you can actually use Amazon SNS to send alerts to Grafana. Okay, what I'm going to do is I'm going to stop sharing, and I'm going to show show the console so we can start working on setting up the AMP workspace. So let's go into the console and actually set up an AMP workspace, and set up ingestion from an EKS cluster and visualize those metrics in Grafana. Okay. All right, so I am actually going to make use of the observability workshop. This is the observability workshop. So you can workshop URL that you can see here. One of those, if you have an EKS cluster with you that you have access to, deploying resources to it, or Kubernetes resources to it, and have admin privileges on the cluster, that is well and good. You would want to clone a repo that I will show you in a little bit to make use of to run some commands. But it will be much more easier if you went ahead and actually deployed the application that is mentioned in this workshop. You can actually use your own AWS account and just follow these tips here. Just use the Cloud9, set up Cloud9, and actually deploy the application. It's only a couple of steps that you need to follow. And once you deploy the application, what will happen is you will be able to see this actually deploys the entire application here that you can see on the screen. So there is an EKS cluster here on the front end. So that is what we're going to primarily make use of. But this workshop actually has multiple components that can actually help you understand a lot more than Prometheus and Grafana alone. Okay, so I'm going to make use of this EKS cluster right here. And like I said, you can use your own EKS cluster. You may not be able to do just a couple of things that I do in the end, but those are additional things. But the main goal here is to make you understand how to create a workspace and set up ingestion from EKS cluster to AMP and query that using Grafana. That'll be perfectly fine even if you had an empty EKS cluster all by yourself. Okay, having said that, let's go to that particular page where we have the details. So here, if you go to the create workspace, here this is where we have the commands. So what I'm going to do is I'm going to go to the AWS console to begin with. So here I'm on the AWS console and I'm in North Virginia. So there are about 5 regions that you can actually use for this particular service. The service is in public preview at the moment. I'm on US East 1. And what we're going to do is we are going to create a Prometheus workspace. So you can create a Prometheus workspace by simply giving a name here, like an alias for the workspace, or you can actually run a command. So what I'm going to do is I'm going to run a command. So here, AWS CLI command is what I'm going to use here. I'm going to say AWS AMP is the managed Prometheus service command. And then we are saying create workspace and giving an alias. So I'm copying that command. I'm going to paste it on my Cloud9. So this is the Cloud9 that was created as part of the workshop. If you have your own Cloud9 or your local machine, that is all fine. Here, now I executed it. Now it's in creating status. Let's go here and let's go to all workspaces. You can see that it's already active. It only took 3 seconds for the workspace to be created. So now I'm inside the workspace and you can see that it's already active and there is a remote write URL. This is the remote write URL and this is the query URL. So the remote write URL is what you would use to send the metrics into the workspace. And just so you know, it took 3 seconds for us to provision a multi-AZ deployed and highly available Prometheus backend. Okay, so I absolutely do not have to worry about storage or API or anything like that. Nothing required. All I need is a collection mechanism now to send the metrics. That's what I did in those 3 seconds, right? So we just have fully available, secure Prometheus backend. So here you can use the remote write URL. That's what we will use in this example to send the metrics to. And here's the query URL, which is what we would use in Grafana to query the metrics from this workspace. Okay, so just remember the name of the workspace is Observability Workshop. All right. So now going back to this, going back to Cloud9. Now I'm here in the next page. So we did this. We created the workspace. I'm going to ingest metrics from EKS page. So what I'm doing is you would need Helm. So Helm, as you know, is the package manager for Kubernetes. That is something that you would need. And I already have Helm installed, so I'm not going to install, but you can actually run this command by just copying here and then running it, and it will actually install Helm and Helm for you in your environment. So that is just a package manager. So once you have it done, it will only take just a few seconds. So once you have that done, you can actually, you need to actually add these charts. So Helm is a package manager, like I said, and Helm has something called charts. So charts are nothing other than just actual packages, right? Those packages have YAML files that Helm can read and deploy the package, the application source. So in this case, I'm actually going to add packages for Prometheus community and Cube State Metrics, and along with it, I'm going to also deploy the Kubernetes node exporter. Okay, so here I'm going to copy this. I actually have it already added, so it's going to say it already exists. But for you, it should basically just install it. And if it says happy helming, that basically means Helm updated the package managers, the packages there. So now that we have the packages created, what I'm going to do, I'm going to actually go and run these commands. So these commands, as you can see, this is actually going to create a namespace called Prometheus in my EKS cluster. And it is going to use this shell script. It's called amp setup irsa eks.sh. So if you did not follow the workshop instructions and set up Cloud9, you will not have access to this file locally, obviously. So to make use of that, go to GitHub and go to this AWS samples one observability demo. Okay, so if you go to that URL, you will see a repo there. So just clone this URL and go to this folder. So let me see if I can go to the 1S site. That is a site that allows you to browse GitHub through VS Code on browser. If you go to that, I want you to go to this location. So resource, and just you just need to go here. So the pet stack folder. So if you can go to this folder and wait there, so that is where I'm going to run the commands from. So the reason why I'm asking you to do that is once you're there, the commands here are built to process from there. So there's actually going to go into the resources directory and going to run this shell script. And those scripts are here inside resources. And you can see that this is the shell script. So this script actually does a couple of things, and I'll tell you what it does. But basically, you need to go into the pet stack folder and be there to execute this. So once you're there, you can copy this and just by clicking on this here, and all you have to do is just paste. And now what is going to happen is it actually created a namespace called Prometheus, and it is now setting up IRSA. So IRSA is IAM roles for service accounts. If you're not familiar with the EKS or the concept of Kubernetes, so Kubernetes has this concept called service account, which is the RBAC or the permission policy mechanism there in Kubernetes itself. So IRSA allows you to map the service account with a IAM role in AWS. So using this, what you can do is you can actually control who can access what resource on AWS. So in this case, the reason why we're using this is we only want the pod that is running that we create in a particular namespace to have access to AWS APIs that we want. So using IRSA is the best way to do that, and I would highly encourage you to read about it. You can just go to the AWS docs and look for AWS IRSA or IAM roles for service account to get a deeper understanding. So what actually happened at this when I executed the script is, if you went to IAM, you would see a new role getting created called AMP IAM ingest role. So inside this role, you will see that there is a policy that got created as well. So this policy actually allows that role to whoever's assuming that role to ingest into Prometheus, okay, or AMP Workspace. So, and it also for IRSA to work, you have to connect the service account to the IAM role, and there's a trust relationship that needs to be made with the OIDC provider in the EKS cluster, and that is all that we do here. So if you don't want to dive deep into this, do not worry, just run that command and you will have the setup. Okay, this is for permissions. All right, so once you have that set up, you are here, and now let's go back to the instructions. And this is the only command that you need to execute to deploy Prometheus server. So what I'm going to do is I'm going to run this command, and it takes like about 20 to 30 seconds, and I'll go back here and explain what that actually looks like. So here, you can see that I'm actually fetching the IAM role ARN that I just created. So this is the role ARN, and I have it in the environment variable, in the workspace ID here, the workspace ID of the Observability Workshop. So that is, the workspace ID is basically here. This is the one. That is what we want here. That has a unique ID to identify which workspace we are talking about. And then we also have, you also need this, and then what we're doing is we're basically using the Helm package manager to install the Prometheus chart into my EKS cluster. So I'm using this YAML file. This YAML file is basically just default Kubernetes configuration. And here, the important things that you want to take notice of here is that I'm annotating the service accounts with the ARN of the role here. This is required for the service account to assume to be associated with the IAM role that we wanted to use. And then we are mapping the remote write URL to the remote write endpoint of the workspace we created. So this will equate to this remote write URL right here, okay? And then the SigV4 region. So SigV4 is a protocol that you need to use to make API calls to AWS APIs. So every time you use an AWS SDK or AWS CLI, they are making calls to AWS APIs. And when they do, they use the SigV4 protocol to make those calls. And that is something that is, if you write your own utility, you don't want to make use of AWS APIs. You can do that if you follow SigV4 protocols yourself. So you can read about it in AWS docs yourself and what that means and how to implement that depending on what language you're using. But the point here is that the Prometheus server is an open source solution, and that can also use the SigV4 protocol, and it gained the capability to do so late last month because the Prometheus server now uses the AWS Go SDK and uses the Go SDK credential provider chain. And the Go SDK uses the SigV4 protocol to make calls to the AWS APIs. Okay, so now when we deployed this basically went and deployed the Prometheus server. Okay, so here when we go back here, let's see if the deployment was successful or not. I'm going to do a get pods, and I'm going to see what is happening there in my pod. So I can see that the Prometheus server is actually up and running, and I told you that this chart also has node exporters. The node exporter is also there, and the cube state matrix is also deployed. So I have everything I need. So node exporter is one of the Prometheus exporters. In Linux, it's basically just a little utility that you can run on Linux machines, and that would collect metrics from the Linux environment and expose in Prometheus format. So in my deployment, what has happened is my Prometheus server can reach into Node Exporter and actually scrape metrics from Node Exporter because my scrape configuration actually does so. So let me show you what actually happened here, right? So let me port forward into that environment and show you how we have configured the Prometheus server. So now I port forwarded into the Prometheus pod that I've deployed. Now I can do it on Cloud9. If you don't have Cloud9, you can actually go to localhost this URL. You'll be able to do it, do exactly what I'm doing. We do preview run application. Let me pop this out into a new tab, and this is going to show me the Prometheus interface. So the moment it comes up, it should ideally have come up now already. Okay, there you go. So here, if I go to configuration, I can go to remote write in configuration. You can see that remote write configuration is actually pointing to the remote write URL that we wanted to point to. So what this means is all the metrics that are being collected are being sent to the AMP workspace. So that is the AMP URL. Okay, so that is one way to set up. So let me get out of that. Close this. Okay, so now that we have our Prometheus server deployed, I also want to show you that I told you in my presentation there are multiple options for you to collect metrics. So now we have set up the Prometheus server to collect metrics and send the metrics to AMP workspace. Now what I'm going to do is I'm also going to show you how you can actually do the same with an AWS distro for Open Telemetry Collector. So you can use the Open Telemetry Collector to collect metrics. In this, you would basically create something called a pipeline. Here I would say there's a Prometheus receiver. So This receiver indicates that there will be metrics in Prometheus format that it needs to scrape from endpoints, and there are processors are something that you would use to allocate memory for the collector and all that. We're not going to do it here in this example, but the other significant thing here is the Prometheus remote write exporter. So there's an exporter in the AWS distro for Open Telemetry Collector that can send the metrics to the AMP workspace. So that's what we're using here. So in my example here, I have the configuration. I'll show you the configuration, but all you need to do is just copy this, right, and execute that command here. So this actually gets the AMP URL and the remote write URL and all that, and it does it. So now if I go and execute the kubectl get pods command, and you can see that my a.collector is already up and running. It was deployed 11 seconds ago. Okay, so the file for that and how that actually looks like is here. This is the I'm sorry, not that file. This file, and this is where in the GitHub repo you have all the configuration. So you have the Prometheus script configuration, but the important thing here to take notice of is how the pipeline itself is set up. So the pipeline is set up here we are saying that here we have the script configuration. Here we're saying here's the exporter. I don't know if the font is too small. Let me try to make it bigger. The remote write exporters remote write, Prometheus remote write, and we replace this AWS region with the actual AWS region, and the remote write URL with the actual AWS remote write URL in the command, and we set the remote write destination for the ADA collector to send the metrics to, and that is what is significant here. So now that we have everything configured, what we have is we have a Prometheus server that is scraping metrics and sending the metrics to AMP, and also we have an a.collector. It can be either or, but in this case, it's for example, for sample sake, and I deployed both. So I have an a.collector that also collects metrics from my application environment. So what that means is I have in this use case, I have an application that is actually sending metrics in Prometheus format, and I'm scraping those metrics from my environment, okay, and sending them to AMP workspace. So now we have everything set up. Now Prometheus is sending metrics to, or my Prometheus server and a.collector are sending metrics to the AMP workspace. Now what I need to do is I need to set up Grafana to query the metrics from that environment, okay? All right, let's do that. All right, so now let's go set up the Grafana workspace and see how we can make use of the managed service for Grafana. All right, so here, let me type AMG, and if I go, I'm opening it in a new tab. Like I mentioned before, I am in US East 1. If you see here, this service is only supported in 2 regions at the moment in public preview. And when we go GA, we'll support all commercial regions, obviously. But right now, you have to be in either one of these regions, US East 1 or EU West 1. Okay, so now let's go see how we can create a workspace. So here, let me give it a name, call it webinar, and I'm going to click on next. So one of the requirements is that you need to have AWS single sign-on or SSO enabled. So this is a prereq. You have to have your AWS account with SSO enabled, and because that is what we'll use the users from SSO to assign users into Grafana. And the permission type, you can be service managed or customer managed. For this purpose, we're gonna leave it to service managed. And you can use in the screen, you can set the workspace to have access to the current AWS account, or you can make the Grafana workspace to have access to multiple AWS accounts in your organization. So that is something you would do here. You can provide the OUID, and you can provide actually multiple OUIDs, and we'll use CloudFormation stack sets to deploy the IAM roles. And so this workspace can assume those roles in those accounts and fetch data from those data sources. So for this example, I'm going to use the current account. I'm going to select all the data sources that I want my Grafana environment to have to be able to talk to, and I'm going to provide Grafana the ability to send notifications to Amazon SNS as well. So SNS is one of the destinations that you can use to send notifications to, but Grafana itself supports other notification options like PagerDuty, Slack, and all that. And it's not, this SNS is in addition to those options. All right, actually, that's pretty much it. If you go and go to the review screen, you will be able to see what the selections you made. And if you click on Create Workspace, it will create the workspace. I have a cap of how many workspaces that I can create, so I'm not going to be able to create at the moment. But I encourage you to go and click on Create. It will take like about 35 to 45 seconds for it to create the workspace. Okay. So once you create the workspace, your workspace, it will appear here in the Workspaces screen, and there'll be a name to it. So if you click on the workspace name, in this screen, you will see that there is a Grafana workspace URL. That is the URL that you'll use to log in to Grafana, and you will see that I have enabled Enterprise that you can actually enable when you for free for 30 days. And that you will see the status of that as well. And you can actually assign users to the workspace. This is actually essential because you need to, Grafana has its own user ID passwords that authentication mechanism. It is not going to use the IAM or the AWS account login. It has its own user ID password that you need to use to log in. So that is why you need to assign AWS SSO users to it. So you can do that by clicking on Assign User and selecting the user that you want to have access to, and like, for example, this, and then click on Assign User, and then that user will have access to that environment. Okay. Now, once the user has access to it, let's say you added your own user, and if you don't have users, go ahead and create those users in SSO, and then refresh the screen, you'll be able to see them in the Assign User screen. And once you have the user assigned, click on the user and make them admin. So if you click on Make Admin, they will become admin, and this will become the user type will show as admin. So I encourage you to do that before proceeding, because you're going to make create dashboards, create data sources, and do a bunch of things that only admin users can do. Okay. All right. So once you do that, here's the URL link that you need to create. This is the Grafana URL. So if you click on it, it will take you to this login screen. So here's the SSO, and Grafana is telling me to log in through SSO. I'm going to click on Sign in with AWS SSO, and I'm going to give my credentials, the SSO credentials, and here's my username and my password. So before I click on sign in, one thing I want to make clear is that if you're using other identity providers, and you might wonder, so do I have to switch my identity providers entirely because you're asking me to use SSO? The answer is no. So you can stay with your identity provider itself. So let's say your identity provider is Okta, OneLogin, or some other identity source. You can actually choose any identity source in SSO. So you can click on Change Identity Source, and actually will allow you to change to any identity source that supports SAML. So you can choose external identity providers, make the connection here. It can even be Microsoft Active Directory, the managed AD as well if you want. So you can use an existing identity provider. So if you did that, the point here is that in this screen, you would see your identity provider's login screen. So it's not the SSO login screen you would see, right? So that's something that I want you to know, that it's not, we're not asking you to switch identity providers, because we're asking you to use the SSO. All right, so clicking on sign in will take me to the login screen. All right, so I am in the Grafana login screen, Grafana homepage, and what I want to do is I want to connect the data source that I created. So here's my, if you go to the AWS logo, there is a plugin, Grafana plugin, that is installed by default with AMG, or the managed service for Grafana. And if you go to AWS services, here you can see all the AWS data sources that we support. Click on Amazon Managed Service for Prometheus, and you'll see that the drop-down automatically is selected, and select the region where your data source is. I selected East 1, that's where my data source is, and you can see that my workspace that I created is showing up. So I'm going to select that, click on Add Data Source, and it got added. I'm going to go to Settings to see what actually happened. Well, webinar data, webinar AMP. All right. So here, here's the URL for the query URL from the workspace. It fetched that. And you can see that it also uses SIG-before authentication. So SIG-before authentication, Grafana supports SIG-before authentication starting version 7.3 onwards. This is not exclusive to AMG. Even the open source Grafana can be made to do so. It also uses the AWS Go SDK in the background. So with this, what that means is you don't have to maintain your own secret key, access key, and go through all that. You can use the SIG-before authentication, and it will use the Go SDK credential provider chain to find the authentication mechanism or the credentials that it needs to use. Okay, all right, so now let's save and test. So the data source is working, that is good. That means that we have a successful data source that we can actually make use of. And that data source is here, so webinar, excuse me, webinar-amp. Okay, so let's see if we can go and explore the metrics. So if I go here, let me select webinar amp, which is the Prometheus data source, and you can see that if the moment you see metrics here, that means there are metrics, and this is, remember, it is actually querying the amp workspace. And if I go here, I can see all the different metrics that are available. So what I'm going to do is I'm going to run a simple simple metric query that I'm going to use. With Prometheus, I can simply give the metric name and click on run query. It will fetch all the metrics. You can see that we just deployed 15, 20 minutes ago or something like that. And here we have all the metrics from the AMP workspace. Okay, so that's really simple. So you can also, you remember we deployed Node Exporter in Prometheus, sorry, in the EKS clusters. That means we configure the Prometheus server to scrape metrics from the EKS nodes. Okay, let's go visualize that. Grafana has built-in dashboards for you to do that. So you can query those dashboards through specific numbers from grafana.com. So you can actually go to dashboards.grafana.com, or you can actually, there are specific numbers for different dashboards that are published. You can actually make use of them. The 1860 is a node exporter metric or dashboard that helps you visualize node exporter metrics. Here, it automatically fetches the name of the dashboard, and I'm going to select the data source that I wanted to use. I'm going to say import. So when I say import, it has imported the metrics from imported the dashboard, and now it is showing the metrics from my AMP workspace that are collected from Node Exporter. You can see that again, these also got started collecting, metrics started getting collected only last 15, 20 minutes or so when we started deploying. This is all the data for the CPU cores and how long it's been up, and RAM, and all those things that you would typically expect expect to see in a node in an EKS cluster, right? Okay, so there's lots of interesting graphics and visualization, obviously, right? So it's quite it takes very little time for you to set it up. Okay, all right. So now that we have this, excuse me, what we can do is we can also take a look at how you can use Grafana to visualize custom application metrics as well. So you remember I told you we deployed a.collector, and we also are exporting some custom metrics. So I have a dashboard that I already built that actually uses custom metrics. So I don't believe this actually uses the data source. So I may have to change that. Data source. I think this is a built-in dashboard, so I won't be able to. So what I'm going to do is I'm going to edit this. I'm going to change the data source. So see here, if you do it, I should be able to run and see the metrics. So maybe I should just explore the metrics. So here, go to the webinar amp. Okay, the metrics are not present, so the application is not up and running. So anyway, so the point here is that you would be able to scrape metrics, so collect metrics from these different workloads. All right, so let's go connect a different data source. So here, Grafana allows you to query, connect multiple data sources. Say, for example, if you can actually connect CloudWatch. So you can see that I already have it connected. It's very straightforward. All you have to do is simply select the region, and you can click on Add Data Source, and it will connect. So here I already have US East 1 connected. with CloudWatch. So let me go and show how that looks like. And this is the data source connection and the settings. And here it comes with some default dashboards. Here are the default dashboards. Here I have a Lambda dashboard, EC2 dashboard, and all that. I told you if you have EC2 metrics, you can see EC2 metrics, Lambda metrics, or anything that you want to see. They're all out-of-the-box dashboards. And again, you can write your own metric expressions and build your own dashboards. I'm going to show you how Lambda dashboard looks like. Here's the Lambda dashboard. So if you deploy the workshop, the Observability Workshop application, you will be able to see this metrics. If not, if you don't have any Lambda functions, you won't be able to see this. But if you have Lambda functions in your account, you would be able to see this as well. So here, these are Lambda metrics, the per function details and all that. So it's all the Lambda metrics. These are all being fetched from the Lambda environment, from the CloudWatch metrics namespace, the Lambda namespace. Okay, so that is that, and also you can we have other data sources, like for example time stream. So I created a dashboard for that. Let's see if we have those metrics. There you go. So maybe in the last 1 hour, and this is also I deployed a default sample application that can actually send metrics to Amazon time stream, and here I'm able to visualize that. I only did it like less than an hour ago, and here's all the metrics here from time stream. So it's really beautiful looking dashboards that Grafana supports. All right. Okay. So and obviously there are other data sources as well. So you can actually take a look at the variety of data sources that we support. Here's the long list of data sources. This is not the full list, as you can imagine. Grafana supports many other data sources as well. When we go GA, we will start adding more data sources, and the plan is to support all Grafana Labs approved data sources when we go GA. Okay. All right. So that is the end of the Grafana demo, and what I'm going to do is I'm going to switch back to the slides and show you one last slide, and we can wrap this up. All right, so hopefully you were able to follow the instructions and you were able to set up all the app workspace and the Grafana dashboards. Having seen all that, now you can see that how observability options or AWS observability options are today with the open source being in the mix. So initially, in the initial slide, I showed you that you have CloudWatch Service Lens and you had all the insights features and all the CloudWatch native inbuilt services and features that allow you to create observability natively with CloudWatch tools. But with the open source options, you have many more options for you to choose from. You can use Grafana to visualize metrics from various data sources. If you, let's say, use Elasticsearch, use X-Ray, use CloudWatch, and you use maybe some other mechanism, your data somewhere else, you can use one visualization tool, in this case Grafana, to visualize all the metrics and all the data from all those different data sources. And you have AWS distro for Open Telemetry to collect traces, logs, and metrics from all these different data sources and so on. So it becomes much more powerful for customers. In certain cases, it can actually overlaps in the sense you can actually make use of CloudWatch metrics and still visualize in Grafana. And at the same time, you can use, you might be using CloudWatch Container Insights and maybe making use of container insights for container monitoring, for in-depth analysis of logs and traces and all that. So it really opens up lots of options for you to choose from. Really, what solution you choose and what solutions you choose, it really depends on your use case and what your long-term direction is looking like. So hopefully you enjoyed this webinar, and hopefully you found this useful. Feel free to provide us feedback, and you can reach me on Twitter at Imaya, and I'm happy to have presented this webinar to you. Talk to you soon. Thank you.